Welcome student to the next lecture, that is lecture number 5, and today we'll be doing the preparation of phenol. There are 4 preparations, and then the first one is from chlorobenzene, and the process is Dow process. Now first I write the reaction and then I'll be explaining how the reaction takes place. Okay, first I take chlorobenzene. This is chlorobenzene, student. I treat this chlorobenzene with NaOH at a temperature of 623 Kelvin and a pressure of 150 atm atmospheric pressure. What product we obtained? We obtained is sodium phenoxide. What we obtained is sodium phenoxide, and this is how it is written. Okay, this is called sodium phenoxide, and this is further hydrolyzed. Acid hydrolysis take place. When I say acid hydrolysis, that means water in presence of some acid like HCl or H2SO4, something like that. Okay, it gives you the product that we want, and we want what? We want phenol. So this is how we'll get phenol, right? But now we have to understand actually how this reaction takes place. Okay, the actual mechanism. Let's see. We have chlorobenzene, student. In halogen derivatives, while studying aromatic arenes, actually, I've explained you that in this reaction, substitution reaction is not that simple. Right, here we can't have, suppose when I treat this with NaOH minus, we do understand that, I'm coming on this part, what I wanted to say, but let's understand here first. Na plus and OH minus, right? This is what we'll get. This is a base, right? And here this OH minus will try to attack, substitute. Whom it is going to substitute? We understand this. With OH minus comes here and Cl will move away. But is it so simple that OH comes and Cl moves away? If it happens like this substitution, normally we think that substitution takes place. But if I think about that substitution, will that substitution be SN1 or SN2? Let's first think of SN2. It will have its antibonding, right? Like this. So if OH minus come and puts electron in the antibonding orbital of this chlorine, so this will move out. But this is not possible. The reason is that because the electron density will be above and below the ring. OH minus cannot come and put this electron into the antibonding orbital of this chlorine. This is not possible, student. Oh, sorry, this carbon. Not chlorine, but this carbon. Right. So this is not possible. So SN2 mechanisms can't take place. Then obviously we think of SN1. SN1 is also not possible because when chlorine moves away, right, then the positive charge ion come to this carbon, and this carbon is sp hybridized, right? Because that is more electronegative, even getting that positive charge on sp hybridized carbon is it's very, very difficult case, because that will make it unstable, right? So what happens? Actually, that's the reason we create this condition, student. Right, harsh condition of what? Such a high temperature, 623 Kelvin, such a high pressure. Under this, what happens? We have to understand. Let's see what happens under this condition. In this condition, suppose this is chlorine. This bonds breaks. This carbon and carbon pi bond. This electron comes over here. Right, why it happens? so that a complete positive charge comes over. See, we can feel like this कि chlorine is electronegative, so it will pulling the electron, but then the charge on this carbon is partially positive, right? So when this bonds break up, this becomes sp3 hybridized and that requires a positive charge, and in that condition that can be possible because now this carbon is sp3 hybridized, right? Okay, so this bonds breaks. When this bonds breaks, something happen like this. Now this acquires positive charge, this acquires negative charge, right? Now in this extreme condition, because it is positive, OH minus comes over here, right? It will form a bond. But now what we understand is that aromatic compounds has become non-aromatic, right? This condition is highly unstable because aromatic compounds reactant ultimately will always form aromatic product. So to regain that aromacity, what happens? This electron makes a bond here again, so it will form aromatic compound, but then this carbon will form a 5 bond, so this bonds breaks up and chlorine moves out as Cl minus, and we do understand Cl minus is stable species, so it will be happy to take that Cl electron and it forms Cl minus, so it moves out and we get a product. What? We get this product. But now you'll feel, sir, the phenol is formed, but here they have shown that we form sodium phenoxide. Actually what happened, I make you understand. So once the phenol is formed, but we do understand that lots many OH minus in the liquid, in that given solvent, because NaOH is there. So this OH minus, because it is a base, it will have tendency to abstract this H. So when you abstract this H, it will form phenoxide ion. Are you getting that, student? Okay, understand. First we'll have chlorobenzene. This mechanism will take place. It will result in formation of phenol. But once this phenol is formed, because OH minus is present in a huge amount, this OH minus is going to abstract this hydrogen. So it will have phenoxide ion. Again, more chlorobenzene will convert to phenol. Again, it will go form phenoxide ion. So in this way, there will be lots many accumulation of phenoxide ion. Right? OH minus will convert all chlorobenzene to phenoxide ion. And once this is formed, what we do? This in the presence of dilute HCl. Right? Means HCl with huge amount of water. That is hydrolysis. Okay. So now in that case, when because HCl is there, it will produce H what? Plus. This is electron deficient, this is electron rich, obviously this is going to attack, and ultimately the product phenol which is formed, and now this is not going to form phenoxide ion. So I hope you understood the whole mechanism. Clear, student? Okay, now in the similar way, similar type, there is a formation of phenol from benzene sulfonic acid. Okay, so we'll take that one because it is similar. From benzene sulfonic acid. Okay, how that reaction take place? I write the first reaction. This is nothing but benzene sulfonic acid. Okay, when I treat this with NaOH, again understand, student, this OH minus is going to abstract this hydrogen. This OH minus is going to abstract this hydrogen. So when this goes away, actually there's a formation of SO3 minus. Although we can write here Na plus just to show that there's a balancing of charge, but actually this Na does not play any role. This is what happens, SO3 minus, right? Got that? Now, because there's a presence of OH minus, understand, now the substitution will take place, student, and the same manner. I can show it like this. What will happen? this OH minus will come. First off, this bond is going to break and comes over here. Negative charge comes over here. This carbon is going to acquire positive charge. OH minus will attack, this will go out. And this does not take place in such a high condition, because when I add here NaOH, the condition is 523 Kelvin. Right, this is 100 Kelvin or 100 degree lesser, because SO3 minus is a better living group in comparison to Cl minus. Right, so when I add this, now OH minus is going to substitute this SO3 minus, and there will be formation of phenoxide. Right, but we have to write like this, but actually there's a formation of phenoxide. Right, then that's very simple. We add dilute HCl. So if forget about this Na, O minus will take H plus, and it result in the formation of phenol, student. This H combines, this O minus will take this H plus, and there's a formation of phenol. Right, so this both is similar type. Okay, obviously the product are different, but this is how it takes place. I hope this is clear. Right, okay, now moving to the next, and that's the very important one. Is from cumin. C. From cumin. Now, what is cumin, student? Cumin is isopropyl benzene. Okay, let's see. I take benzene, and to this there's a group isopropyl CH, CH3, CH3. This is called isopropyl benzene, or is also called as what? Cumin. Okay, we oxidize this. Aerial oxidation take place. Right, aerial oxidation means we just pass air in the presence of cobalt naphthenate. Cobalt naphthenate. Right, at a temperature of 423 Kelvin. Now what happens? See, a student, the bond between carbon hydrogen is weaker in comparison to bond between carbon and carbon. Right, and also we do understand that if oxygen has to be added, it will get added on that part where this carbon is actually not that electronegative. Okay, so this oxygen gets added between this carbon and hydrogen. If I show it like this will be much better. So this oxygen is going to insert between this carbon and hydrogen bond. Right, so the product will be CH3C, this is benzene, O, one more oxygen, and this hydrogen comes and attach over here. This is called cumin hydroperoxide. Cumin hydroperoxide. Right, now this now treated with dilute HCl. Okay, and we heat this. So the product now will be what? Phenol, and we get CH3, C double bond O, CH3. This is nothing but acetone or ketone. Okay, now how it happens, let's understand. First I try to explain in a very simple manner, and then I will try to explain how actual the mechanism would have taken place. Okay, now student, understand, suppose there's a formation of this bond. Okay, you think like this, the bonds break from here. I'm talking very in layman's way, just to realize how this have taken place. Actually the mechanism is different. So suppose this bonds breaks over here, right? And how it breaks, one electron is of carbon over here and one electron for this carbon. Similarly, the bonds also breaks from here, right? So one electron from here. So this electron and this electron will combine to form what? Acetone. And here this OH is going to combine with this. So it results in the formation of phenol, right? But actually it does not take place like this. There's a far more different mechanism, right? So you understood this part, just how to remember this. This is not the actual mechanism, just to remember, right? Now let's think of the mechanism, student. Okay, CH3C here, right, suppose this oxygen, oxygen, H and CH3 like this. Now student, how actual reactions taking place when we add HCl, right? So this HCl is going to facilitate proton, that is H plus, and obviously when this H plus comes, right, the outer oxygen is going to form a bond with that. Okay, when it forms a bond, how it can form a bond? Because when H plus comes, this is in electron deficient, this have excess of electron, so this oxygen is going to provide this, and there's a formation of this product CH3, here it comes benzene, OH, but obviously we understand there is a plus charge, because if this is giving electron to this, it will become positive because there's electron loss and this is gain, right? But now it's not as simple as it used to be before. We have studied in many cases, like suppose carbon is present, right, and OH is present like this. So we understand that this oxygen takes the electron and it moves away in the form of water, and this carbon acquires positive charge. This is we have studied, and we have studied many times, student. But here the case is not that simple. Why it is not simple? The reason, now this oxygen needs electron and it can take the electron from this oxygen, and you know that oxygen is also equally same electronegativity to this of that. So this is not going to provide this oxygen, this is not going to give that electron to this oxygen. Okay, or it can give only if oxygen gets from someone. Suppose somebody gives electron to him, so he in turn can transfer that electron to this oxygen. That is possible. So to facilitate that, what happens, try to understand this bond. Actually there's a migration of some group, and whenever there's a possibility of migration of two or more group, the bulky group can migrate easily, because this is electron rich species and it can easily provide that electron. So here what happens, the bonds breaks from here, and same time the bond is formed. The breaking of a bond and the formation of bond take place simultaneously. Okay, so when this happens, product becomes something like that, CH3 C CH3. See, carbon gives electron to this carbon gives electron to this, so there's a positive charge over here, right? Here oxygen with a benzene ring, and this can moves out now as form of water, so it goes away in the form of H2O. But now the condition is like this. Okay, now what will happen, student? You have to think. Now water which is gone, sorry, I think it was not visible. Again, I'm explaining. This bonds migrate to this, that means this carbon gives electron to this one, so it acquires positive charge and a bond form over here, and this moves out in the form of H2O, right? It comes out in the form of H2O. Now this carbon has become positive charge. So now this is in need of electrons. So who is going to rescue him? Again, this water comes for the rescue. So water comes, right? I'm showing here only OH, right? Lone pair, so it gives its electron, right? When it gives its electron to this, what happens? Let's see. Here, OH, this is H, but now this oxygen has become positive charge. Here, O with the benzene ring. Right, student? Now if we do the hydrolysis, okay, so when I do hydrolysis, what will happen? Let's see here. When I do the hydrolysis, this is going to break. Right, here I will get one H, or you can think like this, because this is positive. Think like this, student. Let's forget about that. There's a positive charge, so this oxygen is going to take the electron, right? So when it takes the electron, this H comes as what? H plus, right? When this H plus comes, this will combine with this oxygen. This has a lone pair of electrons, so this will combine with oxygen. This will come as what? Phenol, right? So this comes at phenol. Here bonds breaks, so it is in need, right? Here it's what? OH. Again, this lone pair of electron going to form a double bond over here, and this H which comes out will combine over here. Are you getting that? Understand, student? This H will comes at a what? H plus, and that H plus is a what? Acid. It again performs the same reaction. So this H is going to combine with this to form a phenol. Here lone pair of electron is there. This is again going to form a bond, and now there's a formation of acetone. So this is the whole mechanism, right? Simple. If not, just try to remember like this. The byproduct is acetone, and acetone is also expensive. So here the byproduct is also can be used, right? Okay. Now, moving to the last preparation of phenol, that is from aniline. From aniline. Right. Now what is aniline, student? Aniline is this compound. Okay. We treat this with nitrous acid, and how this nitrous acid is formed? When we treat this sodium nitrate with HCl, and at a temperature of 273 Kelvin, not Celsius. 273 Kelvin is nothing but 0 degrees Celsius. Means this reaction has to be performed at a very low temperature, right? That is at around 0 degrees Celsius. Now, why that happens? I will actually there's this full mechanism, and that whole mechanism I'm going to explain you when we do the chapter of amines, right? But for time being, you have to understand that it results in the formation of this compound. This is called benzene diazonium chloride. This is benzene, twice nitrogen is called diazo. So this is benzene diazonium. Why nium, student? Because em is added when there's a positive charge. So benzene diazonium chloride. Okay, now when this benzene diazonium chloride is hydrolyzed, okay, what happened? It results in the formation of phenol, and what comes is N2. Okay, now small understanding which is very important over here. Understand, student, this is formed, this is not at all stable, right? And one thing is very important, how this substitution has taken place, how this water is added. See, understand, as soon as this benzene diazonium is formed, forget about the chlorine, right? As soon as this diazonium chloride is formed, benzene diazonium is formed, this nitrogen moves away by taking the electrons. How that is possible? Because if it is moves away, you may ask this question, sir, if this moves away, then the positive charge come on this. See, if nitrogen goes away, positive charge will come on this, and positive charge on sp2 hybridized carbon make it unstable, right? But this actually happens, student, right? Why it happens? Because nitrogen is so stable compound that it does not think anything about what will happen when he moves away to the remaining groups. Okay, he don't care at all. He only thinks about himself. He becomes so stable, so he moves out. This acquires positive charge. As soon as it becomes plus, this water attacks. See, understand how the mechanism will happen. See, this is positive, student. If it is positive, obviously this oxygen water is going to attack, and as soon as water is going to attack, this is acquires what? Positive charge. Okay, when it positive charge form on this, what is going to attack on this? So when positive charge form, we do understand oxygen can't remain positive, so it's going to take this electron, and as soon as it takes the electron, it results in the formation of what? Phenol, and this will come what? H plus, and this H plus is further going to perform the reaction as HCl we use, right? So that's how the preparation of phenol is completed, right? Next lecture we'll be studying about physical properties of alcohol and phenol. For today we stop, student. Thanks for watching.